Welcome back. In this lesson, we're going to continue looking at input devices and why they are required. In this particular lesson, we're going to focus on the keyboard, optical mice, and microphones. So let's begin. Let's start with the most common type of input devices out there, a keyboard. Keyboards are input devices that allow the entry of data and commands by simply pressing down keys. They're often used alongside a mouse and they can be wired or wireless. In the case of tablets and mobile phones, the keyboard is often virtual or a type of touchscreen technology that you use instead of a physical keyboard. Now, frequent use of keyboards can lead to injuries like repetitive strain injuries in the hands and wrist. That's when you type excessively. However, ergonomic keyboards have helped overcome these type of problems. Sometimes the keys are arranged in a specific pattern, and they're also designed to give more support to the wrists and hands when you're doing a lot of typing. Now, the benefits of keyboards are they're very simple and easy to use. You know what you're doing. You press a key and it comes up on screen. And they're potentially a very quick way of entering text-based data. Drawbacks are that they're often quite slow. If you're not a trained typist, you're going to be pressing the keys one by one. And mistakes can often be made because you spell the words incorrectly. However, you should be able to explain the operation of a keyboard, how keyboards actually work. Now, this is the bit that you need to remember for the exam. Each character on the keyboard has an allocated ASCII value, and each character that you press on the keyboard is converted into a digital signal, which the computer then translates into that particular value. So what happens when you press a key on the keyboard? Well, these are the bullet points, and chances are that you'll score a mark for each one. When you press the key on the keyboard, there's a membrane or a bit of circuit board at the base of the keys. So when you press it, it completes a circuit because it touches that. The CPU in the computer can then determine which key has been pressed, and it does that by comparing it to an index file which identifies which character the key press represents. It might be an ASCII or Unicode table here. Each character on the keyboard has a corresponding value in that table, and that is then translated into binary and the CPU processes it. That's all you need to know about how a keyboard operates. Next up is a mouse. A mouse is an input device that allows you to control the coordinates and movement of an on-screen cursor or pointer by simply moving the mouse across a flat surface with your hand. Items can be selected or moved using the left mouse button, and when you press the right mouse button, generally a context-sensitive menu pops up. Now, most mice these days are optical, which means they use a light source or a laser to detect and track movement across the surface. In the old days, there used to be trackballs, and you might see it once in a while. Mice can be wired or wireless. Now, the typical applications for a mouse is to use it in everyday computing for graphical user interfaces, and they're very simple and easy to use, and a very efficient way of navigating on screen. The drawbacks of a mouse, though, are that they require a flat surface and require space to operate. So we are interested in optical mouse according to the syllabus. So what exactly happens in an optical mouse? And this is the bit that you need to remember for the exam. Optical mice often use tiny cameras to take up to 1500 images per second. Unlike older mechanical mice, the optical mouse can work virtually on any surface. A red LED is used in the base of the mouse, and the red light that it produces is bounced off the surface, and then the reflection is picked up by a CMOS chip, which is a complementary metal oxide semiconductor. Now, you don't really need to know these things, but that's just for your knowledge. The CMOS generates electrical pulses to represent the reflected red light, and the pulses are sent to a digital signal processor or DSP chip. The processor can then work out the coordinates of the mouse based on the changing image patterns as it is moved about on the surface. The computer can then move the on-screen cursor to the coordinates in correlation with whatever you're doing on the desktop. Now, you might be asked to compare mechanical to optical mice or wired to wireless mice, and this is for your reference. There are no moving parts in an optical mouse, so they are more reliable, and dirt can't get trapped in any of the mechanical components. There is no need to have special surfaces as well because you're just working with light. Most optical mice use Bluetooth connectivity rather than a USB wired connection. However, there are some benefits of having a wired mouse. There is no signal loss since there's a constant signal pathway, which is the wire. They're cheaper to operate, so you don't need to buy batteries or charge batteries. And there are fewer environmental issues. No need to dispose of old batteries when they expire, so they're still around these days. The final input device for today that we're going to look into is the microphone. Microphones are input devices that take analog sound waves and convert them into electrical signals suitable for a computer to understand. Typical applications for a microphone include mobile phones for making phone calls, tablets and laptops for doing video conferencing, voice recognition systems, things like smart home devices, and even online gaming. Benefits of microphones include the ability to allow people who can't type, like the differently abled, to give instructions to a computer. They enable the use of speech recognition software, as we discussed, and allow voice calls and the audio and video calls, which is using the voice over internet protocol. The drawbacks of the microphone include that speech recognition accuracy can sometimes be hit and miss, and it doesn't recognize all types of accents. Now, this is a bit you need to know for the exam, how microphones work. Microphones are either built into the computer or are external devices connected through USB ports or perhaps even using Bluetooth connectivity. They convert sound waves into an electric current. The current produced is converted into a digital format so a computer can process it or store it, for example, on a CD or an SSD. Now on screen you can see a diagram of the inner workings of a microphone. You can pause a bit and have a look at it. We're going to go through this in a bit more detail next. Okay, so when sound is created, it causes the air to vibrate. When a diaphragm in the microphone picks up this air vibration, the diaphragm also begins to vibrate. A copper coil, which is wrapped around a cone, which is connected to the diaphragm. As the diaphragm vibrates, the cone moves in and out, causing the copper coil to move backwards and forwards. This forwards and backwards motion causes the coil to cut through the magnetic field around a permanent magnet, which induces an electric current. This is basic physics, really. The electric current is then either amplified or sent to a recording device. The electric current is analog in nature, so you need to convert it to a digital signal. This is where, if you're connected to a computer, generally a sound card will convert the current into a digital signal, which can then be stored on a computer. You need to be able to describe this process in the exam. Sound vibrations, diaphragm, cone, copper coil, movement, induction of current, and conversion of current into a digital signal. That's all for today. Hopefully you can answer the following questions. You should be able to explain how a keyboard works. You should be able to also explain how a mouse works. You should be able to give two benefits of a wired mouse over an optical mouse. You should be able to give a use of a keyboard, mouse, and a microphone. And you should be able to explain how a microphone works. Now, if you can't do any of the above, my suggestion is go through the video again, or perhaps leave a question in the comments and I'll get back to you. That's all for now. I'll see you in the next one.